Hey, this is Unit 3, Day 19 notes. These are the first notes since the Day 16 notes. Our objective is to apply the product rule of differentiation analytically, graphically, and numerically. So first question, rewrite the function f of x equals 2x minus 3 times x squared minus 2x plus 1 as a cubic function. Then find the derivative. What does this equation of the derivative represent again? So let's go through and do the distributive property and write f of x, then find the derivative. So we take each and every term in the first parentheses and multiply it by each term in the second parentheses, and now we're going to combine like terms. And now we're going to take the derivative using the power rule. So we're going to take the power rule of each and every term. Derivative 2x cubed is 6x squared. Derivative negative 7x squared is negative 14x. Derivative of 8x is 8, and the derivative of negative 3 is 0. So the derivative is 6x squared minus 14x plus 8, as we just said, and the derivative is a function. Hold on, sorry. I think that's coming up. Derivative is a function that can be used to find the slope of any tangent line drawn to the original function f of x at any x value. So obviously if I let x equal 1, the slope's going to be different than if I let x equal 7. So I just substitute into that new function. Okay, and going back to our day 1, day 2 stuff, and we looked at some of the famous math people that had a part in mathematics, but more specifically calculus. Obviously, the two biggest ones were Newton and Leibniz. So two men, Isaac Newton and Gottfried Leibniz, are credited for developing the study of calculus. In 1673, Leibniz published an article in which he derived what we know today as the product rule of differentiation. So let's write this rule down, and then we're going to use that to do an example. Okay, so if we're given some function is the product of two other functions, so if h of x equals the product of f of x and g of x, then the derivative is going to be equal to, so here's my first function, f of x, then the derivative is equal to the derivative of f of x times just regular g of x, so the derivative of the first times the second, and then we're going to add that to just the first term, f of x, not the derivative, times, and now we're going to take the derivative of the second function. And there's my second function right there. Okay, so this whole thing is the product rule. Derivative of the first times the second plus the first times the derivative of the second. So to show that this rule works, let's apply this rule to the function that we just did, that we rewrote and differentiated as a polynomial. So now we're going to use the product rule for this. So now this is my first term, 2x minus 3, and this is my second term. So now what's the derivative? Well, it's the derivative of the whole function is the derivative of the first function. So 2x minus 3, the derivative of that is 2, times the entire second function, x squared minus 2x plus 1, plus the first function, which is 2x minus 3, times the derivative of the second function. So the derivative of the second function is just going to be 2x minus 2 plus 0. Now I have to go through and just simplify it, but that shows the product rule. So now let's combine like terms. So I just distributed the 2, and then I used the distributive property for those two binomials. So the derivative of that function, 2x squared plus 4x squared, should have been equals. So combine like term, that's 6x squared. Now I have a negative 4x. Combined with another negative 4x will be negative 8x. Combined with negative 6x will be negative 14x. And lastly, the constants, 2 plus 6 is 8. So using the product rule, we get that the derivative is 6x squared minus 14x plus 8. Let's see if that's what we got up above. Hey, that's exactly what we got right here up above. So now, instead of changing everything to a polynomial function or a polynomial-like function, we can just use the product rule, and this will save us some time. So we're going to continue doing these.